Alright guys, welcome back, and we'll start the process of looking at the histogram, and of course we're going to do a quick crash course. Now, as it relates to histogram, what I want you guys to get right away is that the histogram is plotted differently than how we plotted the cumulative frequency curve. Now, if you remember with the cumulative frequency curve, we had cumulative frequency on the vertical axis or y-axis, and then the horizontal axis would be things like score, weight, height, etc. With the histogram, just giving you a rough idea, first of all, with the histogram, the vertical axis is always, big difference now, is always frequency. So with the histogram, it's frequency, not cumulative frequency, as in the case of the cumulative frequency curve. And of course, here would be typical things like height, weight, score, etc. So the big difference right away is that the histogram has frequency on this vertical axis and not cumulative frequency. That's a big difference. Now also with the histogram, there are bars that are essentially joined together. So with the histogram, we have bars that are joined together where they're of the same width, all right? They're attached to each other, and the frequency represents essentially the height of each bar, okay? So the frequency would represent the height of each bar coming across there, all right? And of course, after numbering this axis with the relevant scale, also we're numbering with the scale as well on this axis, but with this scale, after we number, then we locate the class boundaries to get those base or width of the bars established. So essentially, in a nutshell, in order for us to construct a histogram, we're essentially going to be plotting the frequency against the class boundaries. When we did the cumulative frequency curve, this axis was the cumulative frequency. So that's a big difference with the histogram. Sorry about that, gentlemen. The alarm went off on the phone. So I just pointing out this histogram, frequency, and then after numbering, then we locate class boundaries and then get the bars drawn. So this is in a nutshell what the histogram will have a look or what will look like. All right. So let's get into an actual rough example. We're not doing it, this is a crash course, so we're not doing it on graph sheet just yet. What we need to do is just for you to understand how we get the histogram roughly sketched. Okay, so here it says the table below shows the heights recorded for 35 plants, and if you check the frequency, 3 and 8 is 11, and 17, 28, and 634 and 135. So this adds up to give you the 35 plants, and we have 1, 2, 3, 4, 5 classes indicated here. Height is in centimeters, and 10 to 14, 15 to 19, etc. Now what we're going to be doing is establishing the class boundaries. So this will be 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5, 24.5 to 29.5, and 29.5 to 34.5. So again, we will be plotting frequency against the class boundaries. So I'm just going to point this out very clearly, that we will be plotting frequency, not cumulative frequency for the histogram, just frequency, and the class boundaries. So it would be 3, bring this over here. So 3 is going to be plotted against 9.5 to 14.5. 8 is going to be plotted against 14.5 to 19.5. 17 is going to be plotted against 19.5 to 24.5. 17 is plotted against that. 6 is going to be plotted against 24.5 to 29.5, and 1 is going to be plotted against 29.5 to 34.5. So this is what we need to do a rough sketch of the histogram. And of course, when we're doing it on graph sheet, you would definitely need to know the scale for each axis. So this is what essentially we're going to be using. Now, there's something I want to point out right away. The cumulative frequency is used primarily, the cumulative frequency curve is used primarily to estimate median value. When it comes on to the histogram, it is used to estimate the mode, and I'm going to explain how we do that in a sec. But there's a terminology that you need to understand, which is referred to as the modal class. The modal class is that class that has the highest frequency. So this would be the modal class. So I'm just going to indicate modal class right here. Let me just do that in green. So the class that has the highest frequency is referred to as the modal class. Modal class, so it would be this class here, the modal class, because so the modal class would be 20 to 24. Why? Because it has the highest frequency. So this in essence is the modal class right there. Okay, so the modal class based on the data, because it has the highest frequency, which is 17 in this case, the modal class would be 20 to 24. It says modal class, so 20 to 24. So bear that in mind, all right? Modal class. The class that has the highest frequency is referred to as the modal class. All right, so now that we have this information, we can go ahead and do a rough sketch of the histogram. So remember again that the histogram has frequency on the vertical axis, and in this particular case, because we're dealing with heights of plants, this will be height in centimeter. So the frequency is essentially going to represent the height of each bar. So we're going to get that going in a sec. So let's just get the ball rolling. All right, so we need a bar that is of height 3. So we need to count first of all. So let's just establish this. So of course, if we're counting here, of course we'll apply the scale, but we're not doing it on graph sheet now, so doing a rough sketch, crash course. So this is 0, and we can go up by 5, 10, 15, 20, crash course, right? And in this particular case, 5, 10, 15, 20, 25, 30, 35, we can use that as well. So 0 here as well, 5, 10, 15, 20, 25, 30, 35, 40. Now this is a crash course and it's a rough sketch, and I know the extreme values I'm working with, which is why I can just number it that way. All right. So the first thing that we're going to do is just make a note of the heights. These values here for the frequencies represent the heights of the bars. So let me find 3 first of all. So 0, 1, 2, 3. So here is 3. Just indicate that right there. The next one is 8. So 5, 6, 7, 8. So I'm just going to indicate that there. So this would be 8. This would be 3. 17. So 5, 10, 15, 16, 17 would be here. And 1, which is, 6, sorry. 6 would be the next one. 6 is here. And 1 would be the final height. And that's right there. So now I have the heights indicated. What I want to do is pinpoint now the boundaries for here on this axis. So I want to pinpoint the boundary. So where would 9.5 be now? So this is 5, 6, 7, 8, 9. So 9.5 would be between 9 and 10. So I'm just going to indicate this as 9.5. So I'm just going to go ahead and find those. Next one would be 14.5. So we're going to find 14.5. Would be between 14 and 15. So that's 14.5. Just going to number them quickly. Next one would be 19.5. That would be here. So I'm just going to number that. 19.5. 24.5 is the other one. 29.5 would be there. And the last one would be 34.5 which is this. Okay, so seeing that we have that information, we can go ahead and quickly establish our bars. So we're just going to do that quickly. All right, so for the first one, the width of the bar is going to be the same for all, and this one is going to have a height of 3. So 3 is here, so I'm just going to take it over here and obviously just establish that bar there using the boundaries that we've located. So I'm just going to take that up and take this up as well, and this will be our first bar. All right, it's as simple as that. So it has a height of 3. So this one is completed. The next one is again the same width, but 14.5 to 19.5, and it has a height of 8. So 8 is here, and that is gonna just use some dots to go across. And remember that the bars are connected, so that one is 14.5 to 19.5. So all I'm gonna do here is just extend this bar up to that line, just like that. And the 19.5 is here as well. So I'm just gonna extend this up to touch the 8, which represents the height of this bar. All right, so far so good. So this bar has a height of 3, and this bar has a height of 8. So those two are finished. All right, again, focus is histogram, crash course. All right, next one now, 19.5 to 24.5. That's the tallest bar. This is so we're gonna just establish that height, which is up here, 17. And of course, that is 19.5 to 24.5. So I'm just going to take this up. All right, just like that. Just like that. Come across. Just like that. So this one is completed. Next one, the height of that bar is... All right, sorry again, the alarm went off on next time, so apologizing for that. So the height of this bar is 6, 24.5, 29.5. So 6 is here, so I'm just going to just take a dot, carry it across so you see that we're dealing with the height of that bar there. So it's 24.5 to 29.5. So we're just going to carry that up to the 6. All right. And after this, we only have one more bar left. It would be 1, 2, 3, 4, 5 bars. So we have 1, 2, 3, 4. So the next one now would be for 1, and 1 is clearly down here. So we're going to go straight across to this one. The smallest bar, the shortest bar, based on the fact that its height is only 1. And we're just going to take this up and go across like that. All right. So this would be the histogram. So the height of each bar would represent the frequency. So this would have a height of 3, this bar would have a height of 8, this bar would have a height of 17, this bar here, this bar would have a height of 6, and this bar here would have a height of 1. So we've now successfully made a sketch of the histogram for the data that was given in the table. So just going to take this out of the way now so we can focus on that. So remember that the tallest bar, which is this one, the tallest bar here is actually representing the modal class. Okay, so the tallest bar there is representing the modal class because that has the highest frequency, which is 17. Now, to estimate the mode, all we're going to do is a very simple procedure. So I want everybody to pay attention now. This is how you determine or estimate the mode or define the mode using the histogram, right? And remember, with the cumulative frequency curve, it was finding the median or estimating the median, right? With this now, I'm going to show you how to find the mode or estimate the mode. So this is what we're going to do. We're simply going to locate the highest bar, which is this bar, obviously. And I'm going to just use the green marker to just pinpoint here, here, the bars that are attached to it, here and here. Those 4 points there. Here, 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 and here. And all we're going to do is this. To determine the mode using a histogram, just draw a line from the corner here, one corner of the tallest bar, to the next bar that attaches to it at the point where it touches the bar. And then draw a line from this corner, just like that. Now, where they intersect each other, which is right there, where those two blue lines intersect each other, all I'm going to do is draw a vertical line from here, go down to the x-axis. So make sure it's vertical. So I'm just going to take this and draw a vertical line down to the x-axis, and wherever it touches, which in this particular case is there, that is going to be our mode or estimated mode, and that value would be, this is 20, 21, 22. So the mode would be equal to 22 centimeter, and that is a crash course on the histogram. So quickly, the height of the histogram is a frequency. All the widths of all bars must be the same, and after numbering the x-axis, then you locate the boundaries between the values, and that is basically going to represent the lines that come from the base of the bars going up. All right, the tallest bar represents the modal class, and drawing these lines and going down here would generate what we call the mode. So we use the cumulative frequency curve to find median, and we use the histogram to find mode. So, crash course in histogram. I hope you found this video insightful, and I'll see you guys on the next video.